Okay, hello everyone, and let me know if you can hear me very well, and also you can see the share the screen.
I can see and I can hear you.
Perfect, perfect. Thank you. Okay, as I said, we start with short answer problem. I know you already have the key. Good. But we will try to go over this problem together. Okay, just review just in case if anyone has question online or in person, we will just try to explain and solve this problem with more details. Okay, so hopefully, there you go. This is writing. Okay, that's a good news. Uh, I can use this color. Okay. So the question number one, as you can see, the question number one, there is a wave, okay, and this is a displacement over the distance. We have a wave which is, displacing up and down, and then it's traveling through the distance as well, okay? So, and by having this wave, we are supposed to answer the question number one and yes, okay. So let's read the problem together. Below is a standing wave. Okay, so yeah, a standing wave. We already know what is the standing wave. A standing wave is created by the intersection of the incident and reflected wave. So which we have a constructive interference and destructive interference. This constructive and destructive interference can create a standing wave with the first harmonic, second harmonic, third harmonic, fourth harmonic, and so on. Right now, which harmonic this one it is? It is a perfect second harmonic because there is a two loop. Yes. Okay. This is a second harmonic, and it's telling that. So we kind of answer the first one. What is the harmonic that is vibrating? Because we see two loop here, it means that it is vibrating in the second harmonic. Yes, second harmonic. Okay. What is the wavelength of that harmonic? Perfect. We already know that each one of these loops is half a lambda. And what was the lambda? Let's say we have this wave. This is it, just one complete lambda, yes? And let's say we have this wave. The distance between the two peak is the lambda, or the distance between two trough, crest and trough is a lambda, okay? As you can see, each one of these is kind of this part, yes? And also this part. Okay, so what does it mean? It means that each one of these loop is half a lambda. Half a lambda, half a lambda. Okay, so if we had a string and we create this wave, so with these lengths, so half a lambda plus half a lambda is gonna be this distance. Which, what is this distance? It is from here to here, it is 30 meter. Okay, so for solving part B, what I do, let me just erase this part. Okay, we don't need this part. We can use, we can say half a lambda plus half a lambda is equal to, from here to here is 30 meter. 30 meter. Okay, half a lambda plus half a lambda is going to be 1 lambda. 1 lambda is going to be equal 30 meter. What does it mean? It means that the lambda is 30 meter. Okay, this is the part B. Okay, so let's say if there was 3 loops, what we would do at 3 loop, we just right say lambda over 2 plus lambda over 2 plus lambda over 2 is going to be equal to the length of the, let's say this is a string, the length of the string is 30 meter, okay? 30 meter. And then we just solve for lambda, okay? If there was 4 loops, okay? So we just write half a lambda plus half a lambda plus half a lambda plus half a lambda. It means that we have 4 half a lambda. 4 half a lambda equal to the length, which is 30, 4 half a lambda is going to be 2 lambda. 2 lambda equal 30. How we can find 15 meter? Okay, so this is how we can solve. Okay, so but we can have it 2 loops. It means that we are supposed to add 2 half a lambda together, which is going to be 30. So please let me know if you have any question. Okay, so let me just erase these. Okay, so we don't need, this is going to be part B. Okay, part C. What is the S bit of the wave on the string? So if I solve part C, if I just, let me just use different color. Part C, we are supposed to calculate the velocity at this harmonic. Okay, so frequency multiplied by lambda. We already have the frequency for here, yeah? Frequency for the second harmonic is 80 hertz, and the wavelength we just calculated, yep? It is 30 meter, okay? So what is the velocity then? The velocity is gonna be frequency multiplied by lambda. Okay, what is the frequency? 80 hertz multiplied by 30 meter. Okay, when you multiply these two numbers, what you will get? Velocity. Okay, so when you calculate this new number, it's going to be 80 times 30 is going to be 2,400. And we know that hertz is 1 over second, yes? 1 over second time meter is going to be meter per second. Good. And okay, we are done with part C. Now let's go over part D. Okay, read the part D together. Part D, what is the fundamental or first harmonic frequency? So in the first harmonic, how many loops we have? We just have a 1 loop, okay? And we already have the frequency of the second harmonic. Let's say if we had the first harmonic, if the frequency of the first harmonic, if we double these first harmonic, we can get the second harmonic frequency. If we triple the first harmonic frequency, we can get the frequency of the third harmonic. Okay, so what does it mean? How can I write this? Okay, let me just write it here. Let's say part D. Okay, so if I have the first frequency, fundamental frequency, which is 80 hertz, yes? Sorry, not sorry, it is second harmonic, yes? Because I have 2 loops, yes? If I just draw, if I could draw, okay, good. And it's telling that what is the fundamental frequency of the F1. F1 just have 1 loop. We know that if we have the F1, okay, so if we double the F1, we get F2, the second frequency. So what does it mean? There is this relation. F2 is going to be 2F1. What is the F2 already? The F2 is 80 hertz equal to 2F1. Okay? So how we can find the F1? Divided by 2, divided by 2, yes? And then F1 is going to be, or the first frequency, or the first harmonic frequency, or the fundamental frequency is going to be 40 hertz. If the question was asking you, this is not part of the this problem. If it's asking you, okay, calculate the F3. What is the F3? The third harmonic frequency of the standing wave. Okay, what we do? We just multiply. Perfect. Okay, 3 times F1. Good. We already have F1. It's going to be 3 times 40 will be 120 hertz. Again, if we are asked to calculate the fourth harmonic frequency, again, it's going to be 4 times F1. Yes? Okay, 4 times F1 is 40, is going to be 16 hertz. I just wanted to show you, okay, we can just calculate these, okay, for more harmonic frequency, okay? So, and then in this question, we are supposed to calculate just F1. The F1 is just 40 hertz. Good. So we are done with part D. Let's do part E. I want to just use again different color. Now I use the gray. What is the wavelength of the first harmonic? Good question. In the first harmonic, how many loops we will have? One. It means that instead of having these two loops, I will have just this loop, yes? Okay, so let me just draw a little better. See? Good? Okay. So it means that we have one loop. If I just draw it here, I have, it's going to be this, yes? Half lambda. From here to here is 30 meter, yes? So each one of these is half a lambda. Half a lambda is equal to 30 meter. Now, how can I find the lambda? I just multiply both sides by, let me just use the different color. Multiply both sides by 2. 2 and 2 cancel each other, and the lambda is going to be 60 meter. Okay, this is the lambda 1. Okay, what is the 1? 1 means, it means that the wavelength of the first harmonic. Okay, okay. So any question? No? Okay, so this was part E, and then, okay, part F. What is the part F? I use this color. Part F is telling that calculate the amplitude. Okay, let me just erase this. What is the amplitude here? This is a midpoint, yes? The distance from crest to the dash line, or the distance from, the trough to the dash line, yes? It doesn't matter which one. Okay, so the distance from here to here is 10 meter. Okay, this is going to be your amplitude. So the amplitude is 10. Or again, the same thing. The amplitude here is 10 meter. Okay? Okay, we are done with question number 1. Okay, any question? If there is no question, we can start question number 2. Okay, question number 2. Let me just erase these. Okay, we don't need. Question number 2. Question number 2, uh, in question number 2, there are 2 diagrams below. One with respect to the time. Which one is respect to the time? Okay, so displacement. Let's say this is a string and this string is moving up and down, and we just find the wave with respect to the time. Good. So, but the other one is with respect to the distance. Yes. Okay. So it means that it is going to be exactly like the first diagram that we have. Okay, in the question number 1. So, you know, this is a displacement over distance. Good. So this one help us to find the wavelengths, but the first one, which is the time, help us to find the period. Yes? Good. So what I do, okay, so what I do, I'll just try to just read all parts and then answer each part separately. Give the value of the period. Okay. So which graph we can use to find the period? As I said, the period is time, okay? So which graph does have a time? The first graph. So, and I look at this graph, okay? So which is changing with time. What I do here, I'll just try to find the 2 same point on the wave, yes? 2 crests, 2 consecutive crests. The first crest I see here and the second one. And then these lengths give me the time, yes? From here, okay, to here. Good. What are the other 2 same points? Let me just. Perfect. This is again 2 same point, okay, consecutive point in the displacement over time graph, yes? Anyone that help you to find the exact number is gonna give you the period. Okay, so definitely this one is gonna give you the period, yes? This will give you the period as well. They are gonna be exactly the same thing. Okay, from here to here is how many seconds? 30 seconds. Perfect. So we are done. This is gonna be the period time. So part A, T, which is period, is 30 seconds. Good. Part B. Part B is asking us to calculate the wavelengths. Which graph is a perfect graph to give us the second one? Because we have a displacement over distance. Okay? So, again, how we find the period? 2 same consecutive point on the wave. Okay, so how we can find the 2 same point? The only 2 same point here are these 2 crests, yes? So I'll just say this is the first one, this is the second one. The distance from here to here will give me
30 meters.
perfect. It's gonna be my lambda, which is 30 meter. Okay, good. So part B, the lambda is 30 meter. Okay, amplitude. So which one we can use to get the amplitude? Amplitude is displacement, yes? Up and down movement of the it perfect. Either one give you the amplitude, okay? So again, midpoint to the crest or trough, okay? From here to here. What is this? Distance is 10 meter, yep. Let's see the second one as well, okay? Again, yes? To the crest or to the trough, okay? Both are 10, okay? So the amplitude for this question is gonna be, if I use different color, the amplitude will be 10 meter. Okay, so find the frequency. What is the frequency? Frequency is, we already have the formula. Frequency is perfect. 1 over period. We already have the period, yes? Okay, the period is 30 seconds. So 1 over 30, calculate 1 over 30 is going to be how much? 0.033. Yes, if I round it to 3 decimal places, it's going to be 0.033 hertz. Good? Okay. Part is asking me to calculate the velocity. What is the formula of the velocity? Frequency multiplied by lambda. Yep. Do I have the frequency? Yes. Okay. I can use this decimal number or just 1 over 30. Okay, it doesn't matter. Okay. 1 over 30 hertz multiply by, what is the lambda? What is the lambda? 30 meter. Good. Perfect. If I simplify these, what I can get? 30 and 30 cancel each other. So the velocity of these is going to be 1 meter per second. Okay. So part F and G is asking me draw. So what does it mean? It means that I need to clear my both graph. Okay. All my drawing. Erase all my drawing here. Okay. So I'll erase everything. Go to this one as well. Okay. So find it's telling that part F, draw a wave on the first diagram that completely cancel the wave. Okay. How we need to draw to completely cancel? We just draw every point, here in the opposite. Here is 10, yes. Here should be exactly -10. Here is 6, okay. Here should be -6, yes. Here is 0, 0. And then here again, 6 is here, it should be -6. Good. 0. Here is -6 is going to be +6. -10 is going to be exactly +10, yes. And then the same thing. So what does it mean? It means that I need to connect all these points together. Yep. So it's better just to use the points, okay, and then connect these points. Good. So they completely cancel each other. So we call these destructive interference. So because it's kind of destroyed the entire wave, we just have the straight line. Okay, what will be the resultant when you just draw the resultant? I draw the resultant with different color. If you add these two, it's going to be just a straight line. Yes. It seems that there is no wave. Incident wave and then reflected wave, they completely cancel each other, so we have just a straight line. Make sense? Great. In part G is asking us draw a wave on the second diagram that is completely constructed. Okay, we just go to the second wave. We just draw exactly the same wave because it's kind of asking us to have perfectly constructive interference. So if we want to have a perfectly constructive interference, if this the blue wave is or incident wave, if we have a reflected wave, the reflected wave should be exactly the same. Because when they add, let's say if I just say, okay, any point is going to be exactly the same point. Yes. I'm just trying, the one that create good. So connect this point again together. Yep. It should be exactly the same point. Okay. This should be exact. That's how we can have completely constructive interference. Okay. So the difference between the first one and the second one is asking to have completely constructive. So the wave, whatever the wave we draw, it should be exactly the same. But the first one, completely destructive, it means that any point that we have, you need to draw the opposite point. When we connect this point and then add them together, it's going to be this straight line. Good. Okay. So we are done with this part. And what I do, we will move on to the multiple choice problem. We will try our best to go over all problem. And just 3-minute break, okay? Then we will start the multiple choice. Great. Okay, right now we are in the multiple choice part, and I start with the question number 1. There are 47 questions for this multiple choice. We will try to just go over all problem. Okay, hopefully if I can go over all problem, we will try our best. But again, if we couldn't, I'll try to record the rest, and then if you want the second one, I will send you the email as well, or I upload in my D12 shop. So question number 1 is telling okay, let me just see. Okay, question number 1 is telling that a common source of wave motion is, what do you think?
Region of I and O.
A vibrating object, yes? A vibrating object is a common source of, because we need to have an object which has a periodic motion, up and down motion, or circular motion. This is an example of a source of wave. Okay, so the right answer is going to be vibrating object. Okay, so harmonic object doesn't mean, what does it mean, the harmonic object? You know, we can have a harmonic object as long as it's not moving, it's not the source of wave. Yes. Okay. Or region of the variable high and low pressure. Okay, no. Okay, so the perfect answer is the vibrating object. Question number 2, which of the following is not the transverse wave? Which of the following is not the transverse wave? Mm, you know, light, radio are both same source of wave. We call them electromagnetism wave. So whatever is the light is, okay, so the wave, the radio wave is going to be exactly the same thing. So definitely these two are not the answer. So the only one that is left is going to be the sound. Sound is a longitudinal wave. We should know the difference of the longitudinal and the transverse wave. Transverse wave, okay, the medium and the object, okay, the object which traveling through the medium, the displacement of the object is perpendicular to the displacement through the medium, yes? But the transfer, okay, the object motion and its direction of the motion, yes, okay, is exactly in the same direction. Good. So let's say we have a spring and then you're just moving back and forth. Okay, it's gonna be the longitudinal wave. But let's say you have a spring, you are just moving up and down. So it's gonna be the transverse wave. Okay, so the right answer here is gonna be the sound wave. Question number 3. Number 3, how many vibration per second are associated with the 101 megahertz wave? Good. So again, the frequency definition is the number of vibration over time. Okay. So the frequency definition is number of vibration, number of vibration over time. Vibrations over time. So when we have 101 megahertz, what the mega means million, yes? Or 10 to the power of 6. 101 mega means 101 million, yes? How many zero? 60. Good. So, okay. Now I have the frequency. I can say when the frequency is 101,000,000, what does it mean? I can say we have 101 million vibration in 1 second. Or we can say different form as well. Let me just use different color. We can say we have 1 vibration over 101 million second. This is exactly the same as 101 million vibration, yes, over 1 second. That's exactly the same definition. 101 megahertz, it means that 1 vibration over 101. Okay, so what is the right answer here then? 101 million. Okay, 101 million. Okay, question number 4. If the frequency if the frequency of a certain wave is 10 hertz, what is this period? Okay, so again, frequency is 1 over 10, or T is 1 over frequency. They are inversely related to each other. So we already have frequency. The frequency is 10 hertz. So I just need to use this formula. 1 over 10 is going to be 0.1 second. Yep. So what is the right answer then? It's going to be 0.1 second. So question number 5. So let me just make it smaller. Okay. Question number 5 is telling that an object that complete 20 vibration in 10 seconds. Now this is the definition of the vibration. Yes, what's the vibration? What was the frequency definition? Number of vibration over time. How many vibration we have? 20 vibration over how many seconds? 10 seconds. Yes. 20 divided by 10 is going to be 2 hertz. So what is the right answer? Is going to be 2 hertz. So wave interference occur water wave, light wave, sound wave. Yes, it doesn't matter what kind of wave we have. We have a mechanical wave or electromagnetism wave. We always follow the superposition law. Okay, so it means that the wave can cancel each other or it can add each other. We can have a constructive interference or destructive interference. Okay, so What is the right answer then? Okay, perfect, all of them. So question number 7, Doppler effect occurs when a when a source of sound wave.
Either toward you or away from you.
Perfect. It doesn't matter. Okay, so you're moving toward to the sound source, or sound source is moving toward you, or both moving toward to each other, or both moving away from each other. So the frequency and the wavelengths will be different. Good. So that's why the right answer is going to be either toward. An observer, question number 8, an observer on the ground hear a sonic boom which is created by an airplane flying at the speed of, we already know this, okay, so when the s speed is the greater than the speed of the sound, we will have a sonic boom. Yep. Okay. So yeah, greater than the speed of sound. Okay. Good. But again, if you need more explanation, because these are we already discussed in the class, okay? So, but if you need more explanation, just let me know. I will try to explain with more details. So, what was the next one? The source of a sonic boom is, must itself be an emitter of the sound? No. Maybe or may not.
What is a sonic?
Hmm?
What is a sonic boom?
Sonic boom, let's say we have an airplane, okay, and the airplane's velocity become bigger than velocity of the sound wave. Yes. Okay, so what can you, okay. So the airplane, okay, is when the airplane is moving, is creating the sound wave, yes. And then this sound wave, we already know the sound wave velocity is 340 meter per second. If the velocity of the airplanes become bigger than 340 meter per second, so you will hear a sonic boom. If you are standing, because the sonic boom is going to be something like this, okay? So it's going to be something like a cone, yes? So if you are standing in these, at the edge of this cone, yes, let's say you are here or here, the airplane that is traveling, this is the airplane, and these, circles are the, waves, sound waves. Good. So, and the person here who is standing here, okay, hear the sonic boom, boom, boom. This we call it sonic boom. Okay, so at this point, the velocity of the airplane has become bigger than the velocity of the sound which the airplane itself is creating. Good. So that's why, okay, it doesn't matter. The airplane is creating the sound or some other source is creating the sound. We will always have a sonic boom. Okay. So the right answer is going to be maybe or may not be the emitter of the sound. Question number 10. If waves are going by the same speed, the wave with the greatest period of the oscillation is the wave that has, we kind of explain this, yes? Again, if waves are going by the same speed, wave with greatest period, frequency and period are inversely related to each other. Greatest period, it means that the smaller frequency. Yes, if this is big, this frequency is going to be small. What is the velocity? Velocity is frequency multiplied by lambda. If the velocity stays same, if you increase the frequency, yes, the wavelength should decrease until to keep the velocity constant. Okay? Because it's telling that the same speed. The greater period, means a smaller frequency. Okay, sorry, I said vice versa. Let me just, because here, when the frequency decrease, yes, wavelength should be increase. Okay, good. Because the greatest period is a smaller frequency. The frequency, when we decrease the frequency, if we want to keep the velocity constant, we need to increase the wavelength. Okay, so what is the right answer then? Wavelength. Question number 11. A floating leaf oscillate up and down 2 complete cycle in 1 second. So again, this is kind of same problem. Yes, okay. So, and if the wavelength of this is 10 meter, what is the speed? What was the formula of the speed? Frequency multiplied by lambda. We already have lambda, which is 10 meter. Good. And we are supposed to find the frequency. How we can find the frequency? By using this term, yes? How many vibration? 2 vibration in 1 second. So the frequency is number of vibration, 2 vibration over 1 second. It's gonna be 2 hertz, yes? So what is the wave? What is the velocity? So 2 hertz multiplied by 10 meter. 2 hertz times 10 is gonna be 20 meter per second. So question number 12, again, what do you think? The frequency of the second hand on a clock is?
60.
Makes sense, yes? Okay, so the second hand, it takes how many seconds to complete one vibration? 60 seconds. So one, again, frequency is number of vibration, yes? Over time. How many vibration? One vibration, one complete motion over how many seconds? 60 seconds. So it's going to be 1 over 60 hertz. Yes? Okay, question number 10. If it's moving toward you, and then if it's moving,
You're breaking up.
is Can you hear me now? Can everyone hear me?
Yes, now I can, yes.
Yeah,
Okay,
we can hear you, Ollie.
Okay, okay, perfect. Okay, I don't know, something happened. Okay, so okay, I'm glad that we have internet right now. So question number 13, I think yeah, it is 13. It is telling that for we already Okay, we can move on 14. Okay, so for 13, so it is what the answer is moving away from you. Okay, whenever we have a blue shifted, it's moving toward you. Whenever we have a red shifted, it means that it's moving away from you. Good. So what is question number 14? Question number 14. If you double the frequency of a vibrating object, its period, again, period and the frequency are inversely related to each other. If you're doubling the frequency, what happened to the period? Perfect, half. So again, T 1 over F. If you double this, the period is going to be half. Question number 15. What is the question number 15? If it's telling that a floating an object up and down 2 complete cycle in 1 second. So again, I can just write the frequency. Frequency is the 2 complete cycle, 2 vibration over 1 second. Yes? It's going to be how much? 2 hertz. Yes? And it's telling that the wavelength is 5. Okay, the wavelength is 5. You see the same problem. What is the velocity, frequency, time, wavelength? 2 times 5 is going to be 10 meter per second. So what is the right answer then? 10 meter per second. Okay, no question? Is it clear? Okay. Question number 16. A skipper on a boat noticed wave crest. Okay, so wave crest passing the anchor chain every 5 seconds. Let's say this is a skipper. Okay, so and then the wave crest, it is experiencing these two. Yep. The first one and the second one every how many seconds? 5 seconds. So the period is 5 seconds. That's it. This is the meaning of the period. Is experiencing two crests. How many seconds later? 5 seconds later. Okay. So the period, that's it. So we have the period. So the S keeper. Yeah, no, I'm just telling that this sentence has this meaning. So it's telling that, the skipper experienced two crests, he experienced this first crest, yes, and then the second crest, how many seconds later? 5 seconds later. We call this the period, okay? Again, probably it is not asking us to calculate the period, but I'm just still have this meaning. So the S-keeper estimate the distance between these two. Okay, so again, it's telling that the distance between these two, it is how much? Okay, and then we have a lambda as well. Lambda is 15 meter. Okay, so what is the velocity? The velocity is
1/5
frequency time lambda. What is the frequency? We can calculate 1 over t. Yes, it is going to be 1/5 hertz. Okay, so what is the frequency? 1/5 time. What is the lambda? 15. It's going to be 15/5. 15/5 is going to be 3 meter per second. So again, it is important to read the problem to see what kind of information you can get from the problem. It's telling that, okay, so again, the person or whatever, okay, experiencing two crests every 5 seconds. Every 5 seconds, it means that it is a period, yes? And the distance between these two crests is 15. So the wavelength is 15. Now calculate the velocity. Velocity is frequency multiplied by lambda. Calculate the frequency because you have the period, and then you would be okay. Okay, so question number 17. So a jet traveling at 1500 kilometer per hour passes passes between observer A and observer B. In a short time, a sonic boom will be heard. Let's say you are running the airplane, yes? You are the person who is on the sound source because the airplane is creating a sound source. And then, because you are in the airplane, okay, you are moving with the airplane, you are not in that cone.
So just A and B.
A and B observe, okay, but not the pilot. Make sense? Because if the pilot would hear the sonic boom every time, okay, so it would be hard. So the right answer is gonna be observer A and B. So we are question number 18. As a source of continuous sound approaches you at a constant speed, you will be aware of an apparent increasing, okay. Sound source is moving toward you, okay, at a constant speed. What you will hear, you definitely the frequency will be different, yes? The frequency will be different, definitely, because you are blue shifted. You are receiving blue shifted. Blue shifted, it means that the frequency is increasing. And it makes sense. And then what happened to the loudness? You remember the loudness was intensity? Intensity or the loudness level? What is the intensity? Intensity is power over time. Power over time. Okay. And then what is the power energy? If the velocity is increased, frequency is increasing, yes, okay, the power energy is increasing, power is increased. So it means that the loudness and intensity increase. So which one is the right answer then here? The loudness and frequency, okay? Because the wavelengths decrease, okay? The wavelengths decrease. So number 19, if at a concert, if at the concert you run toward an orchestra, the frequency of the sound you will hear will be, again, you are moving toward to the orchestra, yes? And what is this? Blue shifted again. The wavelengths decrease, but the frequency increase. Good. So what is the right answer then? Increase. Question number 20. So a sound source of a high frequency emits high frequency and pitch are kind of same. Yes. Okay. High frequency means high pitch. High pitch means high frequency. So the right answer is just
Pitch.
pitch. Perfect. '21. The approximate range of the human hearing, again, so this is something that you need to memorize. Which one is the right answer?
20 hertz to
Yes.
20,000 hertz.
Perfect. 20 hertz, 20,000 hertz. This is the range of, that a human can hear, the sound with this range of frequency. So number 22, compression and rarefaction are characteristic of
Longitudinal waves.
perfect longitudinal. That's
What's a refraction again?
compression. It means that we have the constructive interference. Rarefaction, when there is a destructive interference. Okay, so the pressure in the pressure of the sound or sound's pressure in the compression is much bigger, or it has its maximum pressure. That's why we call it a compression. In rarefaction, the pressure is very low. Okay, the sound pressure. Number 23. The sound wave cannot travel.
In a vacuum.
Perfect, because sound wave need medium to travel. But light is not like that. Okay, light can travel with medium and in a vacuum. All electromagnetism wave, which the light is part of the electromagnetism wave. Okay, let's say X-ray, gamma ray, radio wave. They don't need, medium to be transferred. But the sound is different. Definitely, the sound, which is a part of a mechanical wave, need a medium to travel. So the sound can travel through the air, water, still, but not vacuum. So question number 24. So question number 24, again, the same definition. Frequency of 1000 hertz, it is 1000
Thousand.
cycle per 1 second.
Yep.
Yeah, 1000 cycle, 1 over the let's say 1000 hertz vibration, yes. Wow.
You're kind of breaking up again.
One volt. Oh, really? Hello? Can you hear me?
Now I can.
Okay, perfect.
Now we're on question 25.
It's behind you.
Behind me? Okay, yeah. We are at question number 24 still.
Oh, it's 1,000 cycles per second.
Yes, yes. It is 1000 cycle per second. I was kind of explaining to the in-person student here. Okay, it is a 1000 vibration per second, or we can say one vibration over 1 over 1000 second, or we call it 1 millisecond. 1 over 1000 second is 1 millisecond, okay? So, or 10 to the power of -3 second. That's both has same definition. So what is the right answer then? The right answer is going to be 1000 cycle per second. So number 25, it is when the speed of sound near the ground is greater than it's at higher altitude, the sound tend to bend,
Upward.
yes, upward. Again, it's telling that when the speed of the sound near the ground is greater than higher altitude, so always the sound travel to just move toward to the air to the less temperature. Yes, okay, so it's going to be upward. So number 26, it is in perceiving its environment, a dolphin make a use of.
All of the choices are correct.
Yes, Doppler effect, ultrasound, and echoes. So all of the above are correct. So let's move on to 27. 27 is the wavelengths of the sound that carry farther in the air are relatively
Long.
the wavelengths of a sound that carry farther in air are relatively,
Long.
again, carry longer, so because they have a longer wavelengths. So this is a long. So let me. The next, but it's size, shape, size, elasticity, size, and shape, and elasticity. You remember in the class we just said size, shape, and elasticity. Size is important, shape is important, and elasticity is important as well. Okay? some singers have been said to shatter a crystal chandelier shatter with their voice. This is a demonstration of, you remember the resonance? The resonance was where each object has its own natural frequency. If external thing create a frequency that become equal to the frequency of, to the natural frequency of that object will more likely shatter. Good. So
Resonance.
yes, resonance is the right answer for this question. So number 30, the phenomenon of bits resolve sound
Interference.
is, again, the phenon, yeah, beats, you remember when we were calculating the velocity of the sound in the class, you would see the graph, compression, rarefaction. Okay, those compression and rarefaction is because of the interference. Those, each one of those peaks, yes, okay, it would 1 bit. Okay, so the bit is created by the interference of the sound wave. So the interference is the right choice, okay, for this. So number 31, in case of radio, which has the higher frequency? Carrier wave, sound wave?
Carrier wave.
Yes. Yeah. No. Sound wave is 340. Okay. So, but the radio wave, okay, so it is almost the velocity of the light. So the carrier wave, okay, is gonna be the right answer here. So because the velocity of the light or the velocity of the radio wave, okay, or electromagnetism wave, electromagnetism is the spectrum of the wave. It can start from the X radio wave to gamma ray. Radio wave with the bigger wavelengths to, and the short frequency to X-ray, gamma, or infrared with the short wavelengths and the higher frequency. But all of them have the same velocity, which is the velocity of light, okay, which is 3 times 10 to the power of 8 meters per second. So number 32. Number 32 probably is kind of the same problem again. So we have a frequency 340 hertz sound. So we just write the frequency 340 hertz sound that travel at this velocity. Again, we just write the velocity 340 meter per second. So we are supposed to calculate the wavelengths. We already know that the wavelengths multiplied by lambda is velocity. If we rewrite this equation, we can just say the wavelength is velocity over frequency. Perfect. 340 meter per second divided by 340 hertz will be 1 meter per second. Yes. So sorry, not 1 meter per second. It's going to be 1
meter.
meter. 1 meter, my bad. 1 meter. Good. So no questions so far?
No.
Question number 33. In which one of these media does sound travel faster?
Ice.
Why ice?
Ice.
The more solid. Yeah. Okay.
Yeah.
Because because the atoms and molecules are so close to each other. The more solid and rigid, the better for the sounds to travel or the velocity of sound. So here, steam, water vapor, and ice, which one the molecules are so close to each other, tied to each other, the ice is. So the ice is the right answer. So 34. the bit frequency produced when 240 hertz, yes, tuning fork and the 246 hertz tuning fork are sounded together. So what is the bit frequency? So, the bit frequency is the absolute value of the frequencies, the difference of the frequencies. Good?
6 hertz.
Yes, perfect. It's going to be 246 minus 240 will be 6 hertz is the bit frequency. So 6 is the right answer. So 35. A general rule for estimating the distance in kilometer between the observer and the lightning bolt is to count the number of seconds between the lightning. Using why?
3.
Yes, it is three. No. Yes. Okay. So it might be, so the lightning and because velocity of the velocity of a okay. The velocity of sound
Ollie, we're losing you again.
meter. Okay. Oh,
Isn't that weird?
here, now, here, oh, what? Can you
Hi, we can't hear you. Yes, the answer
okay,
is 3.
yes, okay. The answer is three, okay, because I was explaining that the velocity of the sound is much less than the velocity of light. The velocity of light is 3,300 million, or 3 times 10 to the power of 8 meter per second, okay, but the velocity of sound is 340. We just use the 3-second rule. So it means that if you see the lightning, you just count until 3 to hear the lightning sound. And again, it's because the difference of velocity of the light and then sound. So it is 3 seconds. So number 36. Each of them and uh, you hear me? Look.
The screen is blank. We can't hear you.
the resume. Okay. Okay. Which question we were? 36. Okay. So what is the right answer for 36?
Frequency.
Frequency is the right answer. Yes. The frequency is the right answer. Why? Okay. So because the pitch of the musical sound depend on its frequency. We just said the pitch and frequency are kind of, the same thing. So what is the next one? 37. The loudness of the musical sound is the measure of the sound wave amplitude.
Amplitude.
Perfect. Amplitude. The bigger amplitude, okay, the bigger the bigger loudness or so good. So these questions are important. Okay, we will have the graph question. We just did this graph question, but just listen to me. Okay, I will expend a little more time on these questions. Okay, so definitely you will have some of these questions or similar question in the exam. So if you couldn't understand, please let me know. I will try to explain more. So we kind of solved the same problem when we started our session. So this one is going to be kind of the same. So, and what we have here, we have a wave, and it's telling that the graph above has the dimension of the G 4 centimeter. So, and then negative G 4 centimeter. So what does it mean? It means that from here to here, 4 centimeter, yes. And from here to here, yeah, probably your numbers is different.
Yeah.
Okay, so just try to learn the concept. The number probably will be different. Yes, okay. So, but again, we are following the same concept. Good. So it's telling that, the dimension is changing from G 4 centimeter. So what does it mean? It means that here 4 centimeter. Yep. And then here is negative 4 centimeter. Good. And then and the y-axis, okay, yes, and the x-axis is from 0 to 190. From here to here is 190. Good. So what I do here, this is a displacement over time. Displacement over time, we can just find the period from here. Okay, when we find the period, we can find the frequency. But the question is telling that calculate the period of these wave in second. So again, when we are calculating the period, and then we have the x-axis which is changing with time, we need to find the distance between the two same point on the wave. Let's say here is a crest, or then we can say from here to, let's say, use this star. Okay, from here to here. But which one is better? This one is better. But we know that from here to here is 190 second. So I need to count these units. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what does it mean? 190 divided by 10 is going to be 19 seconds. What does it mean? It means that from here to here is 9. Yep. Okay.
Yep.
So, but how many of these we have here? 1, 2, 3, 4, 5. Yep. 5 times 19 is going to be or period. Okay. So 19 calculate 19 times 5. It's going to be 95. No, 19 times 5. Yes, yes, it's going to be 95 seconds. Good.
That's the answer?
Yeah, that's the answer. Okay, so yours, if your numbers is different, okay, yeah. So calculate the period. So it's going to be again, the time between two same point on the wave. Okay, when we have a wave displacement over time. Okay, so we already have from here to here is 190 second, because the question says that it is 190 second. Okay, how many of these we need to just count this every rectangle? Yep.
Okay,
Sorry.
so mine says 180 seconds, so we would just use 180.
Yeah,
over 10.
180 divided by 10 is going to be 80 second. Yes. Okay. And then, so 80 time, 1, 2, 3, 4, 5. Okay. It's going to be, 80 times 5 is going to be your period.
Okay.
Good. Yeah. Yeah. Just try to learn the concept. Okay. See how what I'm doing. Okay. You just need to change the number because your number is different. So, good. Okay. So, what is the next one? Now we have this one. Okay. So it is the displacement over the distance. This can help us to calculate the wavelengths. So, but let's say what is the, the graph has the dimension of again 4. Let's say here is 4 to, again here is -4. Good. And from 0 to h, 0 to h is 100. From here to here is how much? 100. Okay, from here to here is 100 meter. How many of these, cube I have, a square I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. 100 divided by 10 is going to be 10 meter. It means that each one of these is 10 meter. Good. And then I'm supposed to find the wavelengths here. Again, the wavelength is the same distance, yeah? From here to here. Why is that right? Oh. Okay, let's see what happened. Oh, there you go. From here to here, good? Or from, let's say, here to here. Which one is better to use? Okay, this one. So how many? We have 1, 2, 3, 4, 5. Okay. What was each one? It was 10 meter. 5 times 10 is going to be 50 meter. Okay. So what is the wavelength here? So the wavelength here is 50 meter. Okay. Good. What is the next one? The same graph, but this time is displacement over time. Yes. So, and it's telling that the G is from 24. The G is from 24 to -24. Here to here is from 24 to -24. And from here to here is 120. Okay, so we need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 120 divided by 10 is going to be 12 seconds. So each one of these is 12 seconds. Yes, 12 second, 12 second, 12 second. So, but what is asking to calculate is amplitude. Okay, what was the amplitude? Yes. Okay, the distance from
I
here.
have a question.
Yes.
Is our chart gonna look like yours? Because the ones that I have only has 8.
Okay. No. Yeah. If it has 8, you need to divide by 8. Okay. So.
Okay,
Yeah. Just try to learn the concept.
I
because-
am.
Yeah. Yeah.
This is hard.
Okay. Perfect. So because your graph may be different than my graph. So it means that if just it is 10 count, okay, so you need to just divide by 10 to find each unit. Good. And if it is 8, you need to divide by 8. Okay. So because this one, okay, we didn't need to just do this calculation. Okay, we just need to calculate the amplitude, okay, from the midpoint to the highest point. is going to be the amplitude. So what is the next one? This one again, displacement over time. So G is from, in my question, G is from 20 centimeter to negative 20 centimeter. Again, the amplitude is here 20 centimeter. Good. But the Y is changing, H is changing from 0 to 20. See? From 0 to 20. Okay? So from here to here again is 20 seconds. Again, I will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 20 divided by 10 is 2 seconds. So it means that each one of these from here to here is 2 seconds. From here to here is 2 seconds. Okay? But what is asking the question to calculate? Frequency. So what is the frequency? We already know that the frequency is 1 over period. So from the graph, we can calculate the period. The time between two consecutive points in the wave. Let's say the time between two crests, yes, here. Or the time between two trough, yes. But I use this one, okay, because it starts from the origin. From here to here, how many of these I have? 1, 2, 3, 4, 5. Okay? 5 time. How many seconds it was? Each one was 2 seconds. 5 times 2, 10 seconds. So the period is 10 seconds. Good? So what I do here, because I'm supposed to calculate the frequency, 1 over. What was the period? 10 seconds. So 1 over 10 is going to be 0.1 hertz. Okay, the frequency is going to be 0.1 hertz. Good? Make sense?
Yes, thank you.
You're welcome. So the next one, which the question, the next one is the last one. Again, we have a displacement over time. Okay, displacement over time, and it's telling that the dimension in the G here again 8, here again -8. Good. So it means that the amplitude is 8 centimeter. Okay. We may need it. Okay, we may not. Okay, but the H is 0 to 80. So again, from here to here, bless you, is 80. I start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. 80 divided by 10 is going to be 8 seconds. What does it mean again? From here to here is 8 seconds. Again, 8 seconds. Good. Each one representing 8 seconds. Each unit representing 8 seconds. But is asking to calculate the, okay, if we already have a wavelength. Good. The wavelength is 170 meter. Good. This is the information that the question given us. We are supposed to calculate the wave speed. What is the wave speed? Frequency multiplied by lambda. We already have lambda. We need to find the frequency. How we can find the frequency? From this graph. This graph helped me because it's changing with time. It helped me to find the period. Yes? Okay. So what is the period again? That is the time between two crests, or the time between two, let's say, trough. Good. Which one is better to use? The top one, because it starts from the origin. Okay, so here to here, give me the period. So how many of these I have? 1, 2, 3, 4, 5. So t is gonna be 5 times what? How many seconds was each one? 8 seconds. Yes, we already calculated. It's gonna be 40 seconds. Okay, so now I have my period. Okay, so I can use this formula. Frequency is equal 1 over period. What was the period? 40 seconds. Okay, go ahead and just calculate this number. 1 divided by 40 seconds is gonna be 0.025 hertz. Good. So this is gonna be my frequency. Okay, now I have my frequency. Good. So I can plug to the formula. What was the frequency? 0.025 times by, what is the lambda? 170. Good. When we multiply these two numbers times 170, it's going to be 4.25. Yes. So the velocity become 4.25 meter per second. Good. So the last one was even, you need to do more calculation, 2-3 step calculation, because you have the graph. The graph help you to find the period, and from period you can calculate the frequency, and then when you have the frequency and the wavelengths, you can calculate the velocity. Okay. Okay. I think we have covered everything. Just the short answer problem, and also the multiple choice question, the blank question. Yeah, please review, all this material, and then good luck with your exam 3.
Thank you.
Thank you.
You are very welcome.